In this video, we'll look at the manifold absolute pressure sensor and how its values would relate to those on a vacuum gauge. MAP sensor data signals engine load and can be used to monitor system operation, such as exhaust gas recirculation. This chart illustrates atmospheric pressure through the various levels of vacuum that we deal with. The red lines indicate atmospheric pressure, while the blue lines indicate a perfect vacuum. The gauge scale, such as that used by a vacuum gauge, starts at atmosphere and increases to a perfect vacuum. Imperial measure using the unit inches of mercury is often used. The absolute scale starts at a perfect vacuum and rises. The two scales cross at approximately 15 inches of mercury. A normal idling engine might achieve a manifold vacuum of 20 inches of mercury on the gauge scale. This would equate to 10 inches of mercury on the absolute scale. The absolute scale might be expressed in kilopascals or pounds per square inch, rising from 0 to approximately 100 kilopascals or approximately 15 pounds per square inch. Where a manifold absolute pressure sensor or MAP sensor is used, values may be expressed on the absolute or gauge scale. If scan data indicates MAP, it's typically on the absolute scale. If scan data indicates vacuum, it's typically on the gauge scale. In this MAP sensor data with the engine off, intake MAP equals barometric or atmospheric pressure. This is a great check for MAP sensor accuracy. When the engine is off, air fills the intake. This is the MAP reading on the vacuum chart. In this MAP sensor data for start and initial run, intake MAP drops to approximately 26 kilopascals. This equates to 22.3 inches of mercury on the gauge scale. This is the MAP reading on the vacuum chart. Intake MAP and vacuum levels remain steady at hot idle. This is the MAP reading on the vacuum chart. MAP decreases or vacuum increases on this hot engine at 2000 RPM. This is a healthy sign. "23 kilopascals equates to 23.2 inches of mercury on the gauge scale. This is the MAP reading on the vacuum chart. At 40 kilometers per hour, intake MAP increases or vacuum decreases due to the increased load. 42 kilopascals equates to 17.6 inches of mercury on the gauge scale. This is the MAP reading on the vacuum chart. This is manifold absolute pressure and MAP sensor signal voltage. With the engine off, signal voltage is 4.73 volts. At startup, manifold absolute pressure decreases, or vacuum increases, and signal voltage is reduced. At hot idle, this engine is running with a manifold absolute pressure of 33 kilopascals with a MAP sensor signal voltage of about 1.2 volts. A snap throttle test simulates full load momentarily and causes a rise in signal voltage. On deceleration, signal voltage is very low due to low manifold absolute pressure or high vacuum.